In this video, we're looking at the first part of lesson 0.3, measuring segments and angles. The essential question that we're going to answer is, how do you use properties of segments and angles to find their measure? Day 1 of 0.3, we're going to focus on how do you use properties of segments to find their measures. In the next lesson, 0.3 day 2, we'll focus on using properties of angles. So before we get started, a little vocabulary that you're going to need to know. The first word is coordinate, and a coordinate is a point's distance and direction from 0 on a number line. So I know we've all seen a number line before. The coordinate is just what number is it on the number line. If we want to know the length of a segment, by the way, when we do length of a segment, instead of putting the segment symbol above it, we just do AB. AB means the length of AB. You find that by taking the absolute value of the coordinate of point A minus the coordinate of point B. So A minus B. For example, if A was at 3 and B was at 8, the length of AB would be the absolute value of A minus B. 3 minus 8 is -5. And then remember, absolute value is the distance from 0. So if it's a negative number, it switches to positive and it would be 5. So the length of segment AB would be 5. Two segments are said to be congruent segments when they have the same length. You can identify congruent segments if they both have the same measure by them, like AB has 2 centimeters and so does CD. That means they're congruent because they're the same length. In a diagram, congruent segments are often marked with little tick marks here. So notice how AB has 2 tick marks and CD also has 2 tick marks. That means that the lengths of AB is equal to the length of CD. So because the lengths are equal to one another, they're both 2 centimeters, we know that the actual segment AB, so this time with a segment, I'm putting that line above it, segment AB is congruent to segment CD. Notice how with segment, we use the congruent symbol. But with the length, we just use the equal symbol. The final word that we're going to define here in this lesson is a midpoint. And we're going to work with this definition quite a bit. A midpoint is a point that divides a segment into 2 congruent segments. So you can see here in this diagram how B is between A and C, and notice how A to B has 1 tick mark and B to C has 2 tick marks. By definition, B is the midpoint of AC, and it's taking that segment again and it's dividing it into 2 equal parts. So segment AB is congruent to segment CD. So make sure you get these 4 vocabulary words written down. Feel free to pause the video. Next, we have 2 postulates. The first postulate is the ruler postulate. And the ruler postulate tells us that the distance between any 2 points on a line is the absolute value of the difference of the corresponding numbers. So we actually wrote that out in symbolic form on the previous slide when we defined the length of the segment. So if I go back to this same picture here, the length of segment AB, so that's AB, equals the absolute value of the difference between the 2 coordinates, so A minus B. That means we could take some numbers here. Let's suppose A is located at -2 on the number line, and B was located at +7. If I wanted to know the distance between those, A and B, you could just go ahead and take the 2 coordinates and subtract them. So -2 minus 7, which is -9. And again, it's absolute value, so that would be a 9 for a length. This next postulate, we're going to use a lot throughout our examples and throughout the homework assignment that you'll do. The segment addition postulate tells us that if 3 points A, B, and C are collinear, so they're on the same line, and B is between A and C, then AB plus BC equals AC. Let's go ahead and mark that on our diagram. AB goes from point A to point B. I just highlighted that in red. BC goes from point B to point C. What this segment addition postulate tells us is that the length of AB, so the red piece of my segment, plus the length of BC is equal to the length of the entire segment, A2C, I'm going to kind of go parallel to that, equals AC. So you can see that the red plus the blue is equal to the green. We're really just taking the segment and we're splitting it out into its two halves. Now that we have our vocabulary words and our postulates defined, let's go ahead and try our first example. Example 1, we're going to use the segment addition postulate. It tells us here if AB is equal to 25, find the value of x, then find AN and NB. Remember, AN means the length of AN, and NB means the length of NB. So one thing you can do is you can kind of mark up the diagram. It tells us here that AB is equal to 25. So if we go from A to B, all the way across that entire segment, it's 25. We also have expressions for the other two pieces, AN and NB. Now notice how together AN plus NB is equal to the entire segment AB. We're also told right here that AB is 25. And we can see in the diagram from the picture that AN is 2x minus 6. So go ahead and sub that in, 2x minus 6, plus NB is x plus 7. And that's going to equal AB, which is 25. Now it's just an algebra equation. Let's go ahead and combine our like terms. 2x plus x is 3x, and a negative 6 and a positive 7 makes positive 1. So 3x plus 1 equal 25. Now we can go ahead and subtract 1 on each side to get 3x equal 24. And finally, to get our answer, just divide both sides by 3, and we end up with x equal 8. So that's the first part of our answer. But now that we know what x is, let's go back and find the length of AN and the length of NB. Remember that AN is equal to 2x minus 6. Since we know x is 8, now we can just go ahead and sub that in. So 2 times 8 minus 6, that's 16 minus 6, which means that AN is equal to 10. Then we can go ahead and do the same thing on the second segment, NB. NB is equal to x plus 7. We found x was 8, so just go ahead and sub that back in. 8 plus 7, which is 15. So NB is equal to 15. And again, I don't know why this keeps coming up. That's a typo. That shouldn't be there. That was from one of my old slides a few lessons ago. Here's another example, just like the one we looked at. I want you to try this problem on your own. Go ahead and pause the video. Ready? Pause the video. So here are your answers. The first thing I did was add EF and FG together and set that equal to 100. I combined my like terms. 2x and 4x makes 6x, negative 20 and 10, or negative 20 and 30 makes 10. And then just solve for x, you get x equal 15. Remember, once you have x, you can go ahead and find the length of the segments by taking that value and subbing them back into the expressions. This next example uses midpoints. Remember the definition of a midpoint. By definition, when something's a midpoint, it takes a segment and it divides it into two congruent segments. So for this example, it tells us that M is the midpoint of RT. Let's go ahead and mark that in our diagram. If M is the midpoint of RT, that means that RM is equal to MT. By definition, the midpoint takes the segment and it divides it into two equal halves. Now we can go ahead and solve for x. Notice how the directions say to find RM, which is the length of segment RM, MT and RT, but before we can do that, we need to find the value of x. So let's go ahead and set the two expressions equal to one another. 5x plus 9 is equal to 8x minus 36. And now we do have a variable on both sides, so let's move all our x's to one side by subtracting 5x from both sides. That gets us down to 9 equals 3x minus 36. Next, we can go ahead and add 36 on both sides. And that brings us down to 45 equal 3x. And we're one step away now, just divide both sides by 3. And we end up with x equal 15. Now notice x equal 15 is not even what we're looking for. The directions here say to find the length of RM, MT, and RT. So just like before, we're going to go ahead and take those numbers and we're going to plug them in. So I'm going to zoom out here a little bit. And let's go ahead and start with RM. RM is equal to 5x plus 9. We just found x, so I'm going to go ahead and sub in 15. 5 times 15 plus 9, that's going to be 75 plus 9, and 75 plus 9 is 84. So there's RM. Now let's do the same with MT. In the diagram, MT, you can see how it is equal to 8x minus 36. Again, we're going to sub in our values here. So do 8 times 15 minus 36. That's 120 minus 36, which is once again 84. So MT is also 84. Notice how those two are equal to each other. They're both 84. That's because if it's a midpoint, they should be equal to each other. So it's a good sign that we got 84 for both of them. Now the last part here, we want RT. And if we look at the diagram, notice RT is just the entire segment. So RT is just RM plus MT. That's the segment addition postulate. So here, if we go ahead and plug in the values we already have, 84 plus 84 makes RT equal to 168. This try now is a little bit different than our previous example, so I'm going to actually go through this problem with you. Notice how there's no picture drawn. When you're not given a picture, it's a good idea to begin by drawing a picture. It tells us here that Z is the midpoint of segment XY. So I'm beginning by drawing segment XY, and then let's go ahead and put Z in the middle. Z is the midpoint. We can even mark XZ and ZY the same. Now it tells us here that XY is 27. Notice how XY, that is the entire segment. We want to know what is the length of XZ. Remember, by definition, a midpoint takes a segment and it divides it into two equal halves. So really, XZ is just half of the total distance. So do 27 divided by 2, and that gives us 13.5. So 13.5. And again, that makes sense. If XZ is 13.5, ZY would also be 13.5. And when you add those together, 13.5 plus 13.5, we're back at the 27. So those are kind of the two types of problems that you would have to do using a midpoint. And that's it for this video. Thanks for watching. Good luck as you try some problems on your own. Bye.